What are isotopes? Isotope is a word that gets thrown around in chemistry a lot. So what are they? Really quickly, isotopes are different versions of an element, or different versions of a certain kind of atom. This can be a tricky concept though, and a lot of people get confused by isotopes. So I want to describe them by starting out with an analogy to cars, okay? I want to talk to you about the made-up car called the Lamona, the epitome of luxury, and it's known for its very distinctive styling. As you'll see, the Lamona looks like a lemon. Now the Lamona comes in 3 different models. There's the Lamona G, the Lamona GX, and the Lamona GXL. They're all different colors, as you can see, but each of these models also has unique features. One has a radio and leather seats. The GX here has chrome wheels and a CD player. It's blue. The red GXL has massaging seats, platinum spinner wheels, and everything. But here's the point. They are all Lamonas. They're all Lamonas because they all have this distinctive styling. They look like a lemon, and that's what makes a car a Lamona, okay? So it doesn't matter what color it is, and it doesn't matter the various options that you get in these models, the GX or the GXL. What matters is that they all have this particular shape. That's what makes a Lamona a Lamona. So we have these 3 different models. I want to use this analogy now to talk about the same thing but with atoms. I want to now introduce you to 3 models of carbon, just the way there are 3 models of the Lamona. Okay? Here are the drawings of each one of them, and what we're particularly concerned about is the nucleus. I'm using these red dots to symbolize protons, and I'm using the blue dots to symbolize neutrons. The swirly circles are supposed to represent electrons that are buzzing around the nucleus, but we don't really want to worry about that too much right now. Anyway, these 3 models of carbon are carbon-12, carbon-13, and carbon-14. Let's look at the options in them. Like we did with the Lamona, let's look at how each one of these different types of carbon differs. Okay? So, if we count the number of protons in carbon-12, we'll see that it has 6 protons, and if I count all the blue spots here, I have 6 neutrons. Okay? Carbon-13, 1, 2, 3, 4, 5, 6. Red spots, 6 protons. In this one, I have 7 neutrons. And in carbon-14 down here, I have 6 protons, and I have 8 neutrons. So what do we have in common here? All the different models of the Lamona, even though there are things that they differed about, all have the same distinctive lemon-like shape. So for carbon, what they all have in common is they have 6 protons. 6 protons in the nucleus. And that's what makes a carbon atom, okay? So it turns out that it doesn't matter how many neutrons it has. 6 neutrons, 7 neutrons, 8 neutrons, no big deal. It's just like painting the Lamona different colors or adding a radio or a CD player. The neutrons, it doesn't matter. It doesn't change the fact that each one of these are a carbon atom. That's because carbon is defined by the fact that it has 6 protons in its nucleus. If you look it up on the periodic table, you'll see something that looks like this, and the number up here is the atomic number, 6, which means that if an atom has 6 protons, it's carbon. Okay? So that's what these all are. They are all isotopes of carbon. They're different versions of carbon or different models of carbon with the same number of protons and different number of neutrons. So look at how I wrote this. I've got carbon-12, carbon-13, carbon-14 up here. I want to take a minute and talk about the numbers. So the number of protons in the nucleus, we call that the atomic number. You may already know that. And then carbon-12, this 12 that I've written here, refers to a different number, and we call that the mass number. The mass number, as you'll see, is the number of protons plus the number of neutrons. So this is carbon-12. 6 plus 7 protons and neutrons is 13 here. 6 plus 8 is carbon-14 here. So that's how we distinguish between these different isotopes, different types of carbon. There's another way that we sometimes indicate these different isotopes, an atom instead of doing 12 and 13 and 14, and that's by using something called isotope notation. Let me show you how we do that. The way we write carbon 12 or 13 or 14 in isotope notation is we start out with a chemical symbol. If you don't already know that, you can find it on the periodic table. So here it is. It's a big uppercase C. So I start with my C for carbon. And then on the lower corner here, I write the atomic number. So that's going to be 6. And then up top, I write the mass number, which is 12. So this is carbon 12 written in isotope notation. Carbon 13 is going to be 6 again, because all carbon has 6 protons in its nucleus. But then the 13 up here. And finally, carbon 14, written in isotope notation, is C614. So that's how we can write all these isotopes of carbon in isotope notation. Then, of course, you can also write it as just the element name with a dash and then the number. So carbon isn't the only type of element that has multiple isotopes. In fact, just like cars, almost every form of element comes in multiple isotopes. Here are the calcium isotopes, for example. If you look up on the periodic table, you'll see that calcium has an atomic number of 20, which means that any atom that has 20 protons in its nucleus is calcium. But just like with carbon, you can vary the number of neutrons that are in the nucleus. You get all these different isotopes, but you still have calcium. Calcium, we've got 40, 42, 43, 44, 46, 48. All of them have 20 protons in the nucleus, but they have varying numbers of neutrons. Just like we did with carbon, we can write all of these calcium isotopes in isotope notation, where we have the mass number here up at the top, and the atomic number down at the bottom. You'll see they all have the same atomic number of 20, but different mass numbers, the sum of protons and neutrons. The same is true for iron, just to give you another example. Iron has 26 protons in its nucleus, an atomic number of 26, and there are 4 known isotopes of iron, all of which have 26 protons in the nucleus, but they all have varying numbers of neutrons. You add these together to get the mass number, and then you can write it in isotope notation with a mass number up here and the atomic number down here. So just to review what we've talked about, atoms come in different versions known as isotopes. These are like the different versions of a car or something. The number of neutrons change, but just as long as you have the same number of protons, you still have the same type of atom, the same type of element. You can take an atom and write it in isotope notation, where you put the atomic number on the bottom and the mass number up here. So that's what isotopes.
Okay, what's an ion? People talk about ions all the time in chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen, though? Well, inside atoms, there are 2 things that have an electrical charge. There are protons that have a positive charge and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore, and it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn 2 things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay? But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has 11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons. So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na. So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom, an ion, what we call any ion that has a positive charge. Okay? Let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charges balance out. The plus and the minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before. So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons and protons. Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge. Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion. But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion. Here's a way that I use to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy, but you can remember this because cats have pos, and a cation is positive. All right? You'll never forget it. I swear, you'll never forget it. Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge. When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, so you have many atoms together that form an ion. I'll talk about polyatomic ions in future videos, so you want to check those out if you need to learn more about polyatomics. Anyway, just to review what we've learned. We learned that an ion is an atom or a group of atoms that have a charge, and something gets a charge when the number of protons and electrons don't balance out. You have more protons than electrons, you'll have an ion with a positive charge, you call it a cation. You have more electrons than protons, you have an ion with a negative charge, and you call that an anion.